Nicolas Carlini has just released a very practical way of benchmarking large language models. He's come up with about 100 different tests based on kind of technical questions from his conversation history. Today, I'm going to show you the benchmark calculations he's done on the main big models like GPT4, Gemini, and Mistral. But then I'm going to modify the code so that I can use a custom endpoint. I'll then show you a comparison with Mistral Large, which is the latest, albeit private, model that has come out from Mistral. And I'll start comparing then the performance of open source LLMs in quantized and not quantized form, and also different sizes, including 7 billion, and also the Mixtral open source mixture of experts model. I'm here on nicolas.carlini.com. This is his blog where he announces the launch of this benchmark. It's open source and available on his GitHub. As the blog describes, this contains a wide variety of tests. I'm going to show you a few of the key ones. It goes all the way from converting Python functions to C functions to writing some bash one-liners. Now, I also recommend subscribing to his writing. He does have a janky Python email list if you want to subscribe right down here. Let's jump right into the results. These are available online, again, on Nicolas Carlini's repo. And you can see he's run the main models. So GPT4, when you go through all of these tests, is scoring 49. Claude, the top model from Anthropic, 31%. Then GPT 3.5, pretty similar to Claude, 30%. Then you have Mistral Medium, which is a private model. It's scoring 25%. Claude Instant scoring 23%. Gemini, now there's a better Gemini model, Ultra, which I'm sure will be tested soon. This is scoring 21%. And Mistral Small, which is actually built on the architecture of the open source Mixtral, the mixture of experts model, is scoring 21%. And I think this gives a really nice picture for how language models perform for technical practitioners, those who are technical, and the ways that they use these language models. You can just see how far ahead GPT-4 is in terms of the performance. And you can see how GPT-3 is really as good as a lot of the other strongest models that are out there. Now, what I'm going to do is modify some of the scripts, and I'll go through step by step how to run them. But first, I'll show you results. I'm going to modify so I can run a custom LLM using Runpod. And I'm going to do a few things. So first, now this isn't using Runpod, but because the Mistral Large model has just been released, I'm going to show you results of Mistral Large, which is their very best, albeit private model. Then I'm going to run a few different models that are open source. I'm going to start by running Mistral Tiny, or the open source 7 billion parameter model. Then I'm going to run a fine tune of that called OpenChat. This is one of my favorite 7 billion models. It performs really well for function calling when fine tuned. And this will give us a view of the performance improvement that you can get just by fine tuning an open source model. So we'll compare the Mistral 7B to OpenChat, which is a fine tune of that 7B model. I'm also going to show you Qwen, the 7B model that just got released. That's the 1.5 version. This one is strong in Chinese and in English, and it supposedly has got very good performance for the 7 billion parameters. And so I want to compare how this performs to OpenChat. To go one step further, I'm going to show you as well the AWQ quantization. This is a 4-bit quantization, and it will help us appreciate the damage that quantization does to the model. And the two other models that I'm going to show are the Mixtral mixture of experts models. So let's just look in that here. I'm going to show you the instruct version, and I'm also going to show you a version that is AWQ'd. So we'll just put in AWQ here, and it's currently being hosted by Eunice. And again, the reason I want to run this is to show you the effect of the quantization on the performance of the model. So before I show you how to do it, let's just show the results. Here we have, I've run just as a calibration, the GPT 3.5 turbo model. This scored about 30% when it was run by Nicolas. You can see it right here. Now, there is one key difference that you'll notice in how I've done evaluations. Every time I've run a test, I've only run one test, whereas Nicolas has been running multiple iterations. I set the temperature very low, so I'm trying to get the most structured and highest probability response. You could also set the temperature a little bit higher and then run more iterations and see if you get kind of an average representation of performance. But both because I like running models at low temperature I think that can give good performance for structured tasks. And also, just to save on time, I've just run with 1 iteration per test per model, and I've also done it at a low temperature of 0.1. So here we have the GPT 3.5 as the benchmark. It's not too far off the score that Nicolas finds, so 33 versus 30. And you can see that Mistral large. When I ran with the Mistral API, I was getting 37%. And where that puts the Mistral large model is above all of the other models apart from GPT4, although it does put it a bit below than GPT4 in terms of performance. The other models I ran are the Mixtral models. So just working left to right, I ran the mixture of experts, and I ran it both unquantized in 16-bit precision and also quantized. And you can see a very significant difference here. And I'm not sure if this is specifically due to the mixture of experts architecture, but there's a very strong performance degradation when you move from Mixtral to the quantized version. When you move to quantized from the 16-bit Qwen model, you see some degradation, but as a percentage, it's a lot smaller than what I saw with the mixture of experts. And you'll see now working from the right that the weakest model of all here is the Mistral 7B model. This is the version 0.1, the first version that was released. It scores only 5% of the questions correct. And interestingly, when it's fine-tuned, that really boosts the performance up to about 12% when you look at the very first version of OpenChat 3.5 that was released. So this shows how doing some fine-tuning can have a very big effect on some kind of technical questions like I'm showing here. Qwen improves even further on OpenChat. It's not a fine-tune of Mistral, it's its own independent language model, although it has a very similar architecture to models like Mistral or indeed Llama. And it performs just as well as the AWQ model for Mixtral. So I thought that was interesting. Now, before I show you how to implement this benchmark, because I think it will be interesting to run for custom models yourself and give you a sense of how these models perform, or a new model that emerges and you want to see if it's any good. Let's just look at a few of the examples here, and we can see just a quick sense of how they work. They're very nicely formatted as well. So here we just have print hello. So the query is to write a program that prints the string hello world and tell me how it works in one sentence. And here's the output from the language model. And then there's some code in the background that will extract the code from the response, and then it will be run through a code interpreter. And that response is then compared in a substring evaluation to tell you whether that's true or not. So there are some of these evaluations that are just being done purely through code. And for some, actually, GPT4 is being used as the judge. I can show you maybe an example here where we have a flag. So here we have easy flag draw, although it's not that easy because only one of the models gets it correct in this case. But nonetheless, it's worth looking at all of the different trials. So we look at the first trial here, and we want to see program that emits a BMP. That's a depiction of an Italian flag. And indeed, it writes some code. And here we will see the Italian flag. And now the way that this has been evaluated is by asking GPT-4. And you can select, by the way, which model to use for evaluation. And it will say what flag is shown in the image. And it says Italy. And then there's an evaluation of that evaluation to check if the word Italian or Italy is in it. And based on that, it will then give you an answer of whether to give a positive mark or 0 to that. Now, interestingly here, you can see in another trial, it didn't even produce a response. It said it couldn't help. That, of course, is a problem with GPT and OpenAI. Sometimes it will just refuse to answer. And you can see in another case here, it provides the wrong colors. And so the flags that's produced is the flag of Mali. And of course, that fails the evaluation. But very nice illustration of how this evaluation works. Now, there are a lot of questions, which I think is also, it's a thing of beauty, some of these questions that are very challenging for the LLMs to get correct. Let's look at whisper merge here. So there are tasks around transcripts. This is a transcript which has a word with some timestamps associated. And there's some tasks that would be nice to automate by blending words into a sentence or combining chunks of this transcript. And so that's what this question is about. It's trying to instruct the model to develop a piece of code that's going to help with merging. So it's asking to write a merge function that calls parse and merges words into sentences that end in period. And then it will run an evaluation on that. Let's actually go back and check out what some of the responses look like. Here's a GPT-4 response. So here we have an output, we have some code, and the code from GPT-4 is being grabbed by the code extractor, and that code is then put through the code interpreter. The code interpreter. And after running that, you can see what the output is, and there are some checks, and it's not giving the exact checks that are expected. And so you can tell then that it's failing. And so tasks like these are still particularly difficult for the language models. Now, I will note that the evaluation is quite good, particularly if you use GPT-4. And I think there is an important point that just because you're using GPT-4 doesn't mean that it can't evaluate itself. Often it's a lot easier to evaluate whether the answer is correct than to actually generate that answer. I don't know if we're getting into P versus NP, where I don't think we are. But in general, I think it's perfectly fine for GPT-4 to do the evaluation, but it's good to realize that some of the evaluation code is not perfect. There could be correct options that end up being showing as wrong. Sometimes the language model will output some headers or some descriptive text that confuses the evaluator, but even though the answer is correct. So some of these answers here may not be correctly evaluated, but in general, I found the accuracy to be quite good. With that, I'm going to give you a demo of how to set up this repository and use it to inference and evaluate a custom model that you're running on Runpod. You could also use any other service. You could potentially host your own endpoint if you have enough VRAM to run your own model, or if you have a GPU to run your own model. You can just put an inference endpoint of OpenAI style on your 8000 or 8080 port on localhost, and then put that URL into the code I'm going to show you. Okay, so we're here on yet another applied LLM benchmark. This is a fork of the original repository, Nicolas Carlini's repository here, that you can check out. There are a few changes that I've made in order to support a custom endpoint. So the first thing I'm going to do is copy, and I'm going to start to clone. So I've copied that GitHub ID. I'm going over to VS Code, and I'm going to just make a test directory here and CD into that. And then I'll do git clone and the repo name here. So once that's cloned, I'm going to open it up in VS Code. And now that I have that open, I'm just going to create a virtual environment in which I'll install the Python packages. So I'll do python-mvenv, and I'll call this evalenv. And then I'll activate the virtual environment. Probably just select it for the space. Source evalenv, then activate. Okay, so the environment is activated here. And now I'm going to take a look at the README to help guide me through the installation. Of course, most of this README has been written by Nicolas, but a few things that I've added in. Now, the first thing to do will be to install the requirements. So we're going to run pip install requirements.txt. And if you want to run some additional tests, you can install extra requirements. So I'm going to go ahead and do that as well. Now, in the meantime, there's something pretty important that I have to say, which is here we're generating a lot of code that we're then going to run. And this creates a risk. The risk is that for some reason, it's not likely, but it's possible that there could be malicious code that's been returned by the language model. And of course, we don't want to evaluate that directly on our machine in case we mess up the machine or get content deleted or worse, content stolen. So the best thing to do is to run on a virtual machine. This can be done either using Docker, or maybe Podman provides an even better degree of separation, as Nicolas explains in the documentation. So I'm going to go ahead and use Podman. Now, just before that, I'm going to install the extra requirements. If you're on a Mac, and you can just directly download Podman on Windows if you go to the website. So on a Mac, if you have Homebrew installed, you can do brew install Podman, and then you want to initialize a machine and then start a machine. I've already got Podman installed, so I just need to do Podman machine init and then Podman machine start, and that should take us all the way. You can alternatively use Docker if you would like, so I'll leave that as an option as well. Now, once you have Podman installed, the next thing you're going to do is build an image. So here I'm going to run Podman machine init, and Actually, I've already initiated a Podman machine because I was working on this earlier. So it looks like my machine is both initiated and it's also started. The next step I'm going to do is some setup. Now, if you want to do a very quick test and not even use your machine, I have created an IPY notebook that you can run within Google Colab. That's a largely isolated environment, and so you have less concern there of running code you get back from the LLMs. However, I think it's probably more comprehensive if you run it on your own machine using Podman. You just can follow more of the scripts that have been developed by Nicolas and some scripts that I've added as well. So you do need to add some API keys for every service you're going to use. And because OpenAI is what you're typically going to use for evaluation, you at the very least need to add an OpenAI key. To do this, you want to go to config.json.example, and you want to copy this file and then create config.json instead. So get rid of the .example at the end. And now you're going to have a list of LLMs. You're going to have a list of custom LLMs that I'll talk you through in a moment. But as I said, crucially, you do need to have at least OpenAI defined here, and you need to have an OpenAI key because that's going to be used for doing evaluation. Now, for each of the custom LLMs that you want to run, and I'm going to run them on Runpod, you want to also list those. And the syntax I've set up is you need to have the model name here as on Hugging Face. You need the API key to be empty because there is no API key if you just set up an OpenAI endpoint. And for the endpoint itself, you're going to set it up like this, which is the proxy address for Runpod. And here is going to be the pod ID. So you'll want to put in your own pod ID here. These are temporary when you start up a pod and shut it down again. And you also need to put in the slug here. The slug is the combination of the owner on Hugging Face and then the model name. And this allows you to direct when you're doing the inference. It allows you to select this specific model. So you can see here I've added in a few different models. Mistral 7B Instruct. I've got the Mixtral model. I've got Mixtral with AWQ. I also have Mistral with AWQ. I have a GGUF. I have OpenChat. And I have a few other models here. Now, I wanted to evaluate Gemma, but Gemma is difficult to evaluate because it actually isn't fine-tuned with a chat format. So the model tends to blab on. This makes it pretty difficult to do inference and evaluation on it. There are some fine-tunes, but it's also difficult to merge LoRa adapters. I think that Unsloth actually supports doing the fine-tuning and indeed merging. So if you really wanted to do it, that would probably be the path for getting a good chat fine-tuned version of the Gemma model. And I'm sure that some will come out over time because it's a relatively new model. Then here I've got the Qwen 7B and the Qwen 72B models here. Okay, so let's go back to the README file. So now we've got the OpenAI key loaded and I've showed you the config for Runpod. I haven't shown you how to set up the pod, so I'm going to do that now. And I'm going to show you as well a few other tweaks that you might want to make in the scripts to set up the default LLM. So here, let me talk through how to set up a pod on Runpod. If you don't have an account already, you're welcome to use the Trellis affiliate link. It does benefit the YouTube channel here if you would like to use it, of course optional. And then you can make use of a one-click template here, which will directly launch this instance of Mistral Instruct. Now, there are many more templates in the Trellis one-click LLMs repo. That's a public repo on GitHub, so you can check that out and I'll put it down below in the description. But for now, just for this demo, we're going to focus on one very simple GPU template. So I've gone ahead and clicked on that Mistral Instruct template, and I'm going to run it on an A6000. You could run it even on, I think, you could run it on an A4000. You could run it on something a little smaller, but I'm going to run it here on an A6000. You'll see that everything is set up, and we'll click continue and we'll click deploy. Now, once we've clicked deploy, we can go and you'll see I'm doing some fine tuning in the background of something else. But here, you'll grab the pod ID and that will allow us to go back and update our config.json file. So I'm going to go ahead and do that for my private config.json file now. So here I've created the config.json and I'm just going to put in the pod ID right here. And just one other thing, that if you're using a TGI, a text generation inference endpoint, you would use 8080. If you're using VLLM and one of those one-click templates, you would use 8000. TGI actually supports an OpenAI style endpoint. So if you hit an OpenAI style endpoint, your endpoint being the TGI endpoint, it will actually allow you to make OpenAI style requests. That API is not quite as mature though. I'm not sure if it allows for batching yet. The general TGI endpoint is typically stronger. Now, TGI tends to be a bit faster than VLLM, so I tend to prefer it. Although when it comes to applying chat templates, which is important in this tutorial because we're relying on the API to apply the chat template, I'm not manually applying it. VLLM tends to be a little bit more robust. So actually, although I'm using a TGI endpoint here with 8080, I often will use a VLLM endpoint. For example, here on OpenChat, I was running it using a one-click VLLM template, which you can find in the one-click LLMs repo. Okay, so once I have my OpenAI key, I'm just going to go ahead and make sure that's in there too. Okay, I have my OpenAI key right in there. And next, I'm going to take a look at llm.py. This is the script that selects the LLM that you're evaluating. And you need to make sure that there's logic in here to support any custom LLM. You can see that I've listed them all here, and this is the key one that I'm going to show you how to run right now. Next, I'm going to scroll down to the bottom where there's some code. Just if you're directly running any of these scripts, there's a default LLM. So we're going to set that to the Mistral default. I'll see here if there's a name that's appropriate. Doesn't look like there is. So I'll just copy a new line and I'm going to take the name of that Mistral model right here. And I'm going to set that as the default for when we want to do evaluation. Okay, now back to the README file. I've added the model to config.json, so that's fine. And I also have updated LLM equals LLM. That's just updating this line here for the default model within that file. As I mentioned, there are plenty more one-click templates you can make use of in the one-click LLMs repo. And I've explained here again the notes I was mentioning around choosing TGI endpoint versus choosing VLLM. The next step now is to build an image. And because we're using Podman, we're going to build an image using Podman. You have to have your Podman machine running. So I have my Podman virtual machine running for this. And I'm now going to run this to build my image. And this image has got a whole set of pre-configurations, and it is going to be called anytime we want to evaluate something. It will be evaluated within that image so that we isolate the image and what happens in it from our computer. Okay, moving on now, we're going to be able to run the benchmark. Before I do that, I have to check if my API endpoint is up. So let's go to the Mistral 7b, and if you just check the logs here, you can see everything's downloaded. It says invalid hostname defaulting to zeros. That means that the API is up. Also because you can see here the GPU usage is max. You know that that's up and running. If you really want to, you can head in here and you can copy this curl command. Just replace the pod ID here. You can put this into your terminal and it will respond back. And that will tell you that the pod is also up. So with the pod up, we could actually go ahead and do an evaluation. If I run this line here, this will immediately evaluate the GPT 3.5 turbo model, and it will do the evaluation of that evaluation using GPT4. The reason for that is because in llm.py, the evaluation LLM has been set to GPT4, and the vision evaluation has also been set to GPT4 vision. So if you want to test a custom model, you're going to have to use a command like this that will point to the Mistral 7b instruct. Now, before you do that, I actually recommend a little test. It's better to just run a short, simple script, which is provided here if you go all the way down. So this simple script will run the print hello command, and you can just see a list of all of these tests, and you can scroll just to see what the print hello looks like. I'll be able to find it here. So this is the print hello script, and it's a short test. But by running this, we can see if the model is working. So I'm just going to run that script for the print hello, and we can see that it's been submitted, submitting the question of writing a simple hello program. And you can even see what the code interpreter is running, and you can see the evaluation of what the code interpreter says, and it's true. So indeed, this model is successfully able to pass the print hello test, and that's how it works. Now, I'm not going to wait for all of the evaluations to run, but let me just show you the code for running evaluations in two different ways. First off, you can run a full model by running this command here. And additionally, if you want, you can specify specific tests. So you could put in a specific test here like print hello, and this should work. Just check that your syntax is correct. Now, if you want to evaluate all of the models at once, what you would do is replace model here and just put in all models. And that will run all of the models that are listed in main.py. I'll show you specifically where they are. Here you can see the list of models to run. For example, here I've listed 2 different models. So this would sequentially run the 2 different models. Now, running the models can be fairly slow. It could take anywhere from 10 minutes to 30 minutes. And actually, it might be quicker to run them in parallel. So set up a different terminal and just run one model at a time. And then you can have the results will each save in parallel. And what I've done is to allow you to view all of the results, even if you've run each model separately, you can run Python generate report. And when you run Python generate report, it's going to create a new HTML file that will summarize all of the results. And here it will show you up all of the models. And in fact, it's showing you all the models that I've already evaluated because I've pushed those up to GitHub. But if you add an extra model, it will just put it in parallel to these. Note that if you try and evaluate again the same model that I've done, it's going to overwrite those results. So that's something to be aware of as well. And that's it for this comparison and review of a very powerful tool, I think, for comparing these different models. Certainly, it's not the only way that you should evaluate, and it's not the last word on how these models compare, but it is a practitioner's representation of how models are being used. And on that basis, I think it is a thing of beauty. Now, I was maybe not so surprised to see GPT-4 ahead. I've seen in practice that represents roughly my experience. I was surprised to see such a difference between OpenChat and the base Mistral model, or perhaps even more to see Qwen be even better than OpenChat. Now, I found some difficulties in fine-tuning Qwen myself for function calling. I'll have a video coming out fairly soon on multilingual function calling. So just because it looks better in one benchmark doesn't necessarily mean that it's going to generalize well to all applications. I think it's interesting as well to see the progress that Mistral have made. Every model they send out, albeit private ones right now, they are improving very rapidly. And now the Mistral Large looks like it's ahead of other models apart from GPT-4. Albeit I didn't have a comparison at this time of the Gemini Ultra model. As usual, let me know your questions below, folks. Cheers.